Hello, ladies and gentlemen, my name is Kurt, and welcome back to NASA's Eyes on the Solar System. This is a program that you can get from NASA. There is a link in the doobly-doo below. It used to be, I had a few videos on this before on my channel, but it used to be a browser, like an in-browser plugin, but it's now a standalone installable exe that doesn't require you to have any sort of extraneous browser plugins or anything, but it's very similar to the space engine or your stellariums or celestias, those type of universe simulators and whatnot, except this one obviously focuses much more on the solar system, eyes on the solar system, but also the current missions that are currently happening through NASA. And you can still get this program even during the government shutdown, even though nasa.gov is currently offline. You can still get this webpage where you can get Eyes on the Solar System is still up and running. Shh! Don't tell anybody in the government. Just be cool guys about it. Just download it and check it out. But anyway, I'm here today because today, October 9th, 2013, the little spacecraft that could, the Juno Spacecraft, is going to be making an Earth flyby. Of course, you know Juno from the time I went to see it launch out of Florida, Cape Canaveral, Kennedy Space Center, Florida. I was invited, lucky enough to be chosen for the NASA Tweet Up, as they were called back then. It's now NASA Social. They invited, how many of us were there? 100? 150 or so social media, Twitter followers, to come down for a 2-day event tour behind the scenes, see the rocket up close, and then of course watch the launch. That was on, when was that? That was on August 5th, 2011. God, that feels like yesterday. But yeah, that was the first and still the only up close from 3 miles away in the press site at the NASA Space Center up close launch I've ever seen, and it was a doozy. That was atop an Atlas V, which is very loud, very cool, very bright midday launch. Bill Nye the Science Guy was right there with us watching, so that was really cool. But yeah, I watched the Juno spacecraft launch from Florida, and now, after 2 years of orbiting the inner solar system, if I zoom out here, and of course we're looking, if you look in the lower left of the screen, we're looking at about the time when I'm planning on releasing this video. And if you note here, it launched, it went out a little bit past Mars and is coming back in for a flyby of Earth, and this is for a boost, a speed boost, a gravity boost, or however you want to term this. It's going to get really close, actually, to the Earth, and the gravitational pull and the momentum carried is what's going to send Juno on its trajectory towards its final destination, and the reason it is out there in the first place, to study Jupiter. So let's actually start to speed things up. This is real rate. This is how Juno looks right now. If you're watching this as I release this video, right now, it is currently 87,000 kilometers, give or take 600, from Earth. And that's looking back at the sun. There's the other orbits of the other planets, of course. It has these solar panels. I've explained this before. This is actually one of the first deep space missions, deep space meaning anywhere outside of the Mars orbit, that is using solar panels as opposed to a nuclear plutonium power source. It's using solar panels. It's constantly rotating at this rate. These are some of the scientific instruments on Juno. Juno is actually quite large. I believe it's 60 meters from tip to tip, so maybe a human is as tall as one of these panels here. So it's not a small thing, but it's out here, and it's going to make a pass today, October 9th, 2013. Its closest approach is going to be at 1922 GMT, which is 3:22 p.m. Eastern Time. So in a couple hours, I am on Central Time, so it's going to be 2:22 p.m. Central Time. So 2 hours, 20 minutes from when this video comes out it's going to make its closest pass, by Earth for that gravity boost. I'm going to speed things up. It's going to start looking really weird. And I could actually zoom out so it's less crazy looking. But Juno is going to... Let's zoom back in. Let's slow down. Slow it up. Okay, I guess we can look a little bit closer to Juno. It looks funny, but here, let's... Juno looking at Earth. There we go. It's actually going to get, if I can time things properly, to 222. It's going to get... Spoilers, wait for it. Right there. It's going to get 559 kilometers from the surface of Earth, which is quite close. Obviously well within the orbit of the moon, obviously, and well below the orbit of many of our satellites. But if we go... What did I say it was going to be? 559? It could get even closer. For reference, that is 347 miles. All right, let's go real rate, and then we'll do that pass by. That is, excuse me, 347 miles. That's about, quite literally, the same altitude that the Hubble Space Telescope orbits the planet at. For comparison, the International Space Station, currently home to 6 astronauts and cosmonauts, is 230 miles. So about 100 miles difference between Juno and where the International Space Station is orbiting. It's pretty dang close. It is quite close indeed. Let's look at Juno so we can actually have a nice view of the horizon. It appears, I believe this is accurate, but it is going to pass over the nighttime sky of the southern tip of Africa, I believe. So not visible. I suppose maybe visible. I don't know. I haven't seen anything in any of the articles about if it's going to be visible. It's certainly large enough. It's certainly close enough. The Hubble Space Telescope is faintly visible from certain points on the Earth. It is in more of an equatorial orbit than the International Space Station, but possibly, but certainly it's not over a very widely populated area unless there are some very lucky people on the southern tip of Africa who might be looking upward at the time. But yeah, it's really cool, and it's going to use this, like I said, as a gravity boost to fling itself around the Earth and then out of the inner solar system and on its final trajectory towards Jupiter. And it is not going to reach Jupiter until July 2016. That is a long trip. Let me zoom out so I can show you. This is the closest it is to Earth, obviously. And there goes the moon orbit. That's Mars. Here's Jupiter. So it's going to do a whole nother orbit, and I could show you that in a second, and then hook up with Jupiter. Jupiter and the solar system is extremely large and far away. Basically, during the flyby, however, NASA is asking for amateur ham radio operators around the world to, in coordination, give a Morse code message of hi, which is just, I think, ... I think, but over a certain time. There's instructions if you look it up, if you are a ham radio operator and you want to send Juno a signal. And that's not just for fun, for funsies or whatever. They believe if enough radio operators do this, the instruments on Juno, specifically the radio and plasma wave detectors, should be able to detect the message from these ham radios, these collective amount of ham radio operators, which would be really cool. You're saying, hi, Juno, and they're using it as a way to test their instruments. I do not believe, I know that Juno has one camera called Juno Cam, but it is not a scientific camera. It is merely an outreach, a publicity camera that they are, once it's in orbit around Jupiter, they're going to open up and allow school children to operate and decide what to take pictures of. But this is purely about data gathering, which I could talk about, I suppose, a little bit. Let me bring Juno out now that we've got as close to the Earth as we're going to get. Let's just take a look at what that does to Juno's orbit. If I can get a little bit more equivalent to the plane. All right, we've swung around and we've interacted with Earth's gravitational field, and I'm going to fast forward time here, and you're going to see it put that little kink in the orbit of Juno. Got a little bit of a speed boost by getting so close to the planet. We know from Kerbal Space Program, when you lower your orbit, when you get close to a gravity well, you tend to have an increased orbital velocity. So that's what that does. And if I fast forward even faster, because this is going to take 3 years, it's going to fling out past the orbit of Mars. Even further, as you can see, it is synced up somehow, sort of, and is going to lead Jupiter. And right now we're looking at August 2014. We're looking at January 2015, still going. 600 million kilometers from Earth. And still 150 million kilometers from Jupiter. And now we are November 2015, and now it's 2016. And let me Juno in. Let me zoom in and slow down. And a boosh, real rate. So yeah, it's June 2016. So July 2016 is when it's actually going to go into a Jupiter orbit. It's going to obviously avoid all of the many, many moons of Jupiter, and it's going to go into this wide polar orbit around Jupiter. And the reason for this is it's going to get so close to Jupiter that all of its sensors are going to be measuring specifically the thermal radiation emanating from Jupiter, and that actually puts the spacecraft and its electronics in harm. If it was orbiting that close all the time, there would be a problem in that it would wear down the electronics so much, the radiation, that it wouldn't last very long. So each of these wide ecliptical orbits are giving Juno a break from the radiation from Jupiter, and it does about 33 of these orbits, and it lasts, these orbits, these 33 orbits happen over the course of, it says in the upper right-hand corner there, 336 days. So almost a year worth of a mission here. And like I said, it's studying the thermal radiation, which will allow, once you get the radiation signatures from within the planet, you can study the abundance and distribution within the atmosphere of water, and therefore oxygen on Jupiter, which we're finding water and oxygen in far much more abundance around the solar system than we thought. It's also going to study the winds that cause those really cool patterns and circulations and storms in the clouds that we can see, the cloud bands. It's also going to study the gravitational field and the polar magnetosphere, because Jupiter has a huge magnetic field so large that it extends past the orbit of Saturn. So when Jupiter and Saturn line up, which is very rarely since they're such far out there, Saturn actually gets influenced by the magnetic field from Jupiter. So that's really cool. They're going to study that, and all this will allow the scientists to understand the makeup, the internal structure of Jupiter, right down to its solid core of liquid metallic hydrogen. Jupiter has a core that is surrounded by a solid liquid metallic ocean of liquid metallic hydrogen. That's craziness. That's metal, man. Literally, that's metal. So that's really cool. And like I said, it's kind of cool for myself to be reconnecting with Juno after I saw it launch from Kennedy Space Center. It's my little spacecraft, I suppose. I still have all of my little badges from the NASA Tweet Up and little artifacts and a t-shirt even. So yeah, like I said, even though in 2016 Juno is going to be 671 million kilometers from Earth, right now, it's going to come within 559, 2 hours from when this video goes live at 3:22 p.m. Eastern Time, 2:22 Central, and that would be 12:22 p.m. Pacific Time, which equates to 19:22 GMT. I suppose while I'm here, I can wrap this up by saying that after it does its 33 orbits, and that's pretty much all the electronics and the instruments are designed for, but we of course have had in the past NASA instruments out there last much longer than they've been designed for. But as it stands now, after these 33 orbits, they are going to, let's go to the deorbit stage. They are going to deorbit, like we know in Kerbal Space Program. It's going to do a little bit of a burn at its apoapsis, which is going to easily bring the periapsis down. And Juno is going to be deorbited into the atmosphere of Jupiter, and that will end the mission. This is, of course, to This is a kind of a newer, I suppose, rule that NASA has imposed upon itself to rid the solar system of debris. They don't want eventually 10, 15, 100 years down the line for Juno, this dead spacecraft, to run into one of the moons of Jupiter and contaminate it. Obviously, we want to keep these things as pristine as possible so that we can study them and know the origins. So in order to do that, they are going to purposefully deorbit Juno into Jupiter, and it has that one camera. I suppose I don't think they're going to be able to get any footage or images because of simply the data rate it would take to then transfer the images. The spacecraft would be dead by the time they were able to transfer any images via the radio to the planet Earth, and the instruments aren't really set up to take measurements as it enters the atmosphere. It's pretty much just gonna blow up, not blow up, but burn up. Just a little spark, a speck. Barely a gentle breeze on the surface of Jupiter is what Juno will cause. But yeah, cool stuff. So even if you don't have your ham radio up and running, you can today, I suppose, generally look up towards the sky and wave to Juno and wish her well on her again 3-year journey now away from Earth and towards its mission on Jupiter. So yeah, like I said, this is NASA Eyes on the Solar System. Link in the description below. If you want to grab this yourself, you can explore, of course, the Juno mission, but there are also, let me see, how do I do this? There are also, you can just freeform look around, the different planets and check out all the other missions that are happening. A really cool free program. It has all these spacecraft to explore and things you can learn about the universe, the solar system specifically, and have fun like this stuff. So yeah, Juno, go Juno, and thank you very much for watching. My name is Kurt. I will see you next time.